Hi everyone, here we are going to continue the topic that we started in the last video, that was domain and range. So if you want to watch that video, please click on the I button on the top right corner of the screen. So let's start with the first question. Find the domain and range of these functions. So here the first function is f of x equals x minus 2. We know that domain means the set of all the possible input values. Here you can see that we can put any real number in place of x. We can put a positive number, a negative number, a fraction, a decimal. That means here the domain is going to be the set of all the real numbers. Now if we see the range, then that is also going to be the set of all the real numbers. Let's try to understand it with the help of some examples. So let's say that your x is negative 4. Then your f of x is going to be negative 6. That is negative 4 minus 2. When your x is 0, then your f of x is going to be negative 2. When it's 2, then your f of x will be 0. For 4, it would be 2. You can even take a decimal number. So let's say we are taking 5.5. Then it is going to be, your f of x is going to be 3.5. So you can see here that whenever we are taking any real number value for the input x, for the output which is f of x, we are again getting a real number. That means here your range is going to be the set of real numbers. Now let's move on to the next question. So here the function is h of x equals 2x to the power of 4. So you can see here that we can take any number in place of x. I can take x to be 1, to be negative 1, to be 100, to be 3, 4, 4.5, right? So just like the previous question, here also the domain is going to be the set of all the real numbers. Now let's understand that how we can find out that what would be the range of this function. Now let's take some random values of x and then let's see what output are we getting. So if x is negative 1, then your h of x will be equal to 2 times negative 1 to the power of 4. Now we know that negative 1 to the power of 4 is 1. That means h of x will be equal to 2 times 1, that is 2. Let's say x is 0. Then we are going to get h of x as 2 times 0 to the power of 4, that is 0. For x to be negative 4, let's say, then it would be 2 times negative 4 to the power of 4. That is going to be 2 times 256. That is basically 512. Now let's take some positive values for x. So let's say I'm taking x to be positive 1. Then h of x will be 2 times 1 to the power of 4. That is 2. If x is 2, then we will get 2 times 2 to the power of 4. That is 36. And so on. We can take so many examples here. We can even take decimal numbers, fractional numbers, right? Any real number value for x. Now what you must be seeing here, that every time we are getting the answer great as equal to 0, right? Or greater than 0. So you can see here that other than 0, all our answers or all our outputs are always positive. Now the output can never be negative here. There is no chance of that. Why? Because anything raised to the power of 4 is always positive, like we did in the examples also. If you do negative 1 to the power of 4, that's 1. If you do 1 to the power of 4, that's also 1. If you do negative 2 to the power of 4, that's 16. 2 to the power of 4 is also 16. So no matter what you do, any number raised to the power of 4 is always positive. So 2 times a positive number is always going to be a positive number, except 0. When you take x as 0, then you will get 0 as the output. Remember, 0 is neither positive nor negative. That means the smallest output that you can get is 0, and after that you can get any positive number as your output. So your range is 0 to infinite. Now let's see the next question. Here we have g of x equals 1 by x. Now again we have to figure out that what all values can x take here. Now you must have studied about fractions and rational numbers before, and there we have really well studied that the denominator of any rational number or a fraction cannot be 0 ever. So because we know that any number, let's say a, divided by 0 is always undefined, right? That means here again x can take any value. X can be 1, 2, -1, -2, right? Anything. But x cannot be 0 here. Always remember that whenever you are having a function where it is of the form of a fraction, then make sure that your denominator is never equal to 0, because that will result into an undefined answer. That means your domain is the set of all the real numbers except 0. So whenever you have to exclude any number from your domain or range, you put a minus and then you put the curly braces, and inside that curly braces you put the number that you want to exclude. So here you want to exclude 0, that's why I have put 0 here. Now let's see what would be the range of this function. We have done so many questions, so I would like you to pause the video and try to figure it out yourself, that what can be the range of this function here. You can take some random input values and try to see that what pattern you are seeing in the output. Okay, so let's see. So I'll take some random values of x, like I said. So if x is 1, then our output g of x is also going to be 1. If x is 2, then g of x will be 1 divided by 2. That is what? That is 0.5. If x is 3, you will have 1 divided by 3. That is 0.33 and so on. So we can even again take some negative values, decimal numbers, not an issue, right? Like let's say that x is -4, then we will have 1 divided by -4, which is going to give us what? Which is going to give us 0.25, actually -0.25. So you can see here that the answers are revolving around 0 here, right? They are all near to 0. But again, we can take any number for x. So even I can take a very small number, let's say 0.005. So when you will do 1 divided by 0.005, you are going to get 200 as your answer. Then similarly, you can take many small values for x, like 0.0009, 0.000078, right? Anything. And you will see the smaller the denominator is going to be, the bigger the value of gx will come out. Like let's say that x is 0.0008. Now when you will do, let me write this down, right? X is 0.0008. Now when you will divide 1 by 0.008, 0008, you will get 1250 as the answer. So like I said, the smaller the denominator becomes, the bigger g of x will be. And the bigger the denominator is, the smaller your gx is going to be. So here we can see we are getting all real number values for y, for g of x. That means here your range is going to be the set of all the real numbers, but except there would be an exception here. you can see here that we can never get 0 as the answer. Because to get 0 as the answer, we should have 0 divided by any number. That means 0 should be in the numerator. But that is not possible here. Why that is not possible? Because here the numerator is already fixed. It's 1. So it doesn't matter whatever x is going to be, you will never have 0 as the answer. That's why here your range is also going to be the set of all the real numbers except 0. Let's see part D. X to the power of 3 plus 4. Now here remember that whenever we are having anything to the odd power, right? So here you can have a positive answer for x to the power of 3 as well as negative answer to x to the power of 3. Like if we do 3 to the power of 3, that is 27, right? But if we do negative 3 to the power of 3, then the answer is negative 27. So basically if your x is negative, you will get a negative answer. If your x is positive, you will get a positive answer. That means this x to the power of 3 can be positive as well as negative. And again, you know that you can take any value in place of x, right? That means here your domain is going to be the set of all the real numbers again. And again, the range will also be the set of all the real numbers, right? Because here also you can see this can be positive as well as negative. And then you will add 4 to it. So let's take some examples here. Let's say x is negative 1, right? If x is negative 1, then your f of x will be negative 1 plus 4. That would be 3. If your x is negative 2, then your f of x will be negative 8 plus 4. That is negative 4. If your x is negative 3, then your f of x will be negative 3 to the power of 3 plus 4. That is negative 27 plus 4. That is negative 23. Now let's say we are taking some positive values. So let's say I am taking x as 1. In that case, f of x will be 7. If your x is 2, then f of x will be 15, and so on. So you can see here for all the real values of x that you are taking, your output y, or we can also say f of x, is also coming out to be a real number here. So that's why the range of this function is also going to be the set of all the real numbers. I hope that is clear here. Okay, now let's see this one. Here g of x equals square root of x minus 5. Now remember that whenever we have to find the domain of any function, there should two things that we should always check. First, that we should never have a 0 in the denominator. That only happens when we have a fraction. And the second is that we should never have a negative number inside the square root. Like we should not have square root of negative 6 or square root of negative 25. We only have positive numbers inside the square root. Now, why am I saying so? Like, let's say I ask you that what two numbers you should multiply to get 25 as your answer. Then there are two possibilities. You can multiply 5 times 5 and negative 5 times negative 5. But it doesn't matter that whether you take positive numbers or negative numbers, the square always comes out to be positive. We can check for negative 6 squared, that's 36. Positive 6 squared, that's also 36. And you know that here, the square root of negative 25 means that what two same numbers we should multiply to get negative 25. And that's not possible because whenever we multiply the two same numbers, that means we find the square, that is always positive. So remember that always inside the square root, we will have a positive number, or even we can have 0, right? So that means we always need to check that what should you put in place of x so that your number inside the square root comes out to be greater than or equal to 0. So to check that, all we have to do is whatever expression is inside the square root, you put that greater than equal to 0. So x minus 5 should be greater than equal to 0, and when we solve this inequality, we get x should be greater than equal to 5. That means here our domain is the set of all the real numbers that are equal to or greater than 5. So in interval notation, we can write it like this. Now you can even check this out. If we take any number less than 5, let's say we are taking 3, then 3 minus 5 gives you square root of negative 2. And as we have already discussed, that should not happen. But if you take any number greater than or equal to 5, let's say we are taking 7, then 7 minus 5 and its square root is square root 2, whose value is approximately 1.414. So you can see here that any value of x that we are taking to be greater than or equal to 5, we are always going to get an answer greater than or equal to 0. But for any value less than 5, we will get a negative square root. That is why here our domain is going to be from 5 to infinity. That means after 5, you can get any positive number as your answer. Now, if we talk about the range, you know that the smallest value that you can take here for x is 5. So when you are taking your x as 5, your square root of x minus 5 will be square root of 5 minus 5, that is equal to square root of 0, which is 0. That means the smallest output that you will be getting corresponding to 5 is going to be 0. And after that, you are going to take many more values of x, right? 6, 7, 8, 10, 20. You will always end up with a positive answer. That can be any positive real number. That means here your range is from 0 to infinity. Now that's all for this question. Let's see the next part here. Again, very interesting question. So f of x equals x squared minus 16. So again, just like the previous question, we know that here x squared minus 16 should be greater than or equal to 0. So we'll do it like this. X squared minus 16 should be greater than or equal to 0. Now we have to figure out that for what values of x, this expression will always be greater than or equal to 0. So if you see that when we take x equal to 4, then we will get x squared minus 16 as 4 squared minus 16, that is 16 minus 16, and that is 0. So you can see here that when we are putting x as 4, we are getting 0 as our output, right? Or basically 0 for x squared minus 16, right? Now, is there any other value that we can put in place of x so that we can get 0 as the answer? So the answer to it is yes. If we take negative 4, then also what would happen? Negative 4 squared minus 16 will be equal to 16 minus 16, that is again 0. So you can see there are two values, 4 and negative 4, for which we are going to get x squared minus 16 as 0. So let's see on the number line here. So here we have 0, here we have negative 4, and here we have positive 4, right? Now let's try to check all the values between negative 4 to 4 and see what happens to x squared minus 16. So let's say if our x is negative 3, in that case what would happen? Negative 3 squared minus 16, that will be equal to 9 minus 16, that is negative 7. But you know that your x squared minus 16 should be greater than or equal to 0. Similarly, you can try taking negative 1. When you take negative 1, you will get negative 1 squared minus 16. That will be 1 minus 16, that is negative 15. Okay, again you are getting a value that is less than 0. Now let's take some positive value of x that lies between negative 4 to 4. So this time I will take 3. Now when we take 3, then again 3 squared minus 16 will give us 9 minus 16, that is again negative 7. So what I'm trying to explain here is that any value of x that will lie between negative 4 to 4 will result in this becoming less than 0. Now let's check for the values that are less than negative 4. So let's say we are taking negative 5 here, right? So if we take negative 5, then we get negative 5 squared minus 16. Now you can see negative 5 squared is 25. So 25 minus 16 is 9. Right? That is greater than or equal to 0. It's satisfying the inequality. If we take negative 6, even then we'll get negative 6 squared minus 16. That will be 36 minus 16. That will be 20. So again, this is satisfying the inequality. That means all the values that are less than negative 4 will also satisfy this inequality. That means negative 5, negative 6, negative 100, right? Similarly, if you take any value of x that is greater than 4, you can check this out, right? So let's say this time we are taking positive 5. So positive 5 squared minus 16 is also 9. And positive 6, if we are taking x to be positive 6, then positive 6 squared minus 16 is 20. So again it is greater than or equal to 0. That means what? That all the values that are less than or equal to negative 4 and that are greater than or equal to 4 are going to satisfy this inequality. That means here what is going to be our domain? Domain, now see how I'm writing this, right? Now what is going to be your domain? It is going to be all the numbers less than or equal to negative 4. So I'm going to write this in interval notation. How can you represent all the numbers less than or equal to negative 4? You can write it like this. All the numbers from negative infinity to negative 4, which is included here, right? And then after that, you know that all the numbers from 4 to positive infinity. That means in interval notation, you can write it like this. And now you know that both of these intervals are going to be a solution for this inequality. So if you have to, write the overall solution, then you put this sign. This is the sign for union. Basically, it means that plus, right? That this interval plus this interval is going to be the set of the x values that you can take for this function. So this is your domain here. Now if we see the range, then you can see here that the square root is always positive, right? By convention, we always take the value of square root to be positive. So like if I say what is the square root of 16, that's going to be positive 4. What is the square root of 25? That is going to be positive 5. So here the function is again of square root. So we are clear here that it is of course going to be what? A positive number. That means your range will be here what? All the positive numbers, and it can also be 0. When it will be 0? When your x is negative 4 or 4. In that case, you know that for negative 4 and 4, your output is going to be 0, right? So that means here your range is what? You can write it like this. Your range is f of x, that is your output, is greater than or equal to 0. Another way of writing this is in the interval notation, that is closed interval 0 to infinity. Now this is all about this question. So now here the function is f of x equals 4 divided by x minus 2. Now we very well are aware now that the denominator should never be equal to 0. That means we will see that for what value of x can the denominator be 0. So if we will solve this this equation, we will get x is equal to 2. So that means we are clear that here the domain is going to be the set of all the real numbers except 2. And if we see the range, since the domain or x can be any real number, that means the range can also be any real number. But again, remember that it cannot be 0 because you do not have 0 in the numerator, right? And you can only have 0 as the answer if 0 is divided by any number, which is not happening here since the numerator is fixed. That means your range is the set of all the real numbers except 0. That is all for this video. If you have really been able to understand these questions and have gained something meaningful from this video, please do hit the like button, subscribe the channel for the latest videos, and stay tuned. Thank you so much.